Greeting everyone. Welcome to today's presentation. We are here to introduce a highly important and beneficial technology called SSD cache. This technology plays a crucial role in the field of data storage and management, bringing significant improvements in performance, cost savings, and optimized data access speeds. Traditionally, data was stored on rotating memory, or HDDs, and SSDs. HDDs were mainly used for high-capacity storage, while SSDs were reserved for fast but costly applications. However, HDDs' capacity growth has outpaced their random I/O speed. For high-performance tasks like web commerce, clouds, and virtualization, SSDs have become more appealing due to their increased capacity and lower costs. SSD cache technology blends HDDs and SSDs to fulfill enterprise app needs. Data primarily resides on HDDs, with SSDs acting as extended memory caches for I/O operations. SSD caches enhance app performance, especially for I/O-intensive workloads. Frequently accessed read data is copied to the cache, while write data is stored temporarily and then bulk written to HDDs, delivering instant performance enhancement. Kaizen SSD cache guarantees consistent app performance by handling read-write surges at SSD speeds. Another plus is improved TCO. SSD cache moves hot data to SSDs in chunks, allowing low-cost, high-capacity HDDs to handle most IOPS after cache. This mix of minimal SSD and ample HDD offers cost-efficient, power-saving peak performance. An SSD cache pool provides capacity for dedicated storage pool (SSD cache) usage. The system allows up to 4 SSD cache pools, whether it's a dual controller or single controller setup. Here's the SSD cache pool storage architecture. For SSD read cache, consider SSD cache pool 1. This pool consists of one or more SSDs, using nRAID plus, explained later. These SSDs are designated for pool 1. Up to 8 SSDs can be part of this cache pool, which can be expanded or shrunk by adding or removing SSDs. For SSD read-write cache, take SSD cache pool 2 as an example. Multiple SSD groups, each comprising 2 SSDs, in nRAID 1+, form this pool assigned to pool 2. Expanding the cache involves adding a complete SSD group with 2 SSDs at once. Up to 4 SSDs can be designated as dedicated hot spares in this cache pool. The SSD read cache typically employs nRAID or RAID 0, lacking data protection, to establish SSD cache storage. However, our SSD read cache technology employs nRAID plus, a parallel version of nRAID that avoids striping. nRAID combines free space from multiple drives to create a span capacity. It encompasses various drive types and sizes, mainly serving as a span volume. On the other hand, RAID 0 uses striping but lacks mirroring or parity. Integrating a drive into RAID 0 necessitates data restriping, which can adversely affect SSD cache performance, especially alongside cache operations or RAID 0 migration. In contrast, nRAID Plus distributes cache data across all SSDs. This technology amalgamates nRAID's strengths and delivers superior random I/O compared to standard nRAID. Moreover, nRAID Plus allows easy addition or removal of SSDs from the cache pool to adjust capacity. Despite SSD read cache duplicating data, if the SSD cache pool becomes corrupted, the original data remains secure, but the SSD read cache functionality ceases. The SSD read-write cache requires data protection and often employs RAID 1 or RAID 10 to establish cache storage. Our SSD read-write cache technology utilizes nRAID 1+, a parallel nRAID with mirroring. RAID 10 constructs a striped set from mirrored drives. Similarly, incorporating a pair of disk drives into RAID 10 demands data restriping, complicating SSD addition to the cache pool. In contrast, nRAID 1 Plus distributes cache data across all mirrored SSDs. This technology offers data protection and superior random I/O compared to RAID 10. Moreover, it allows easy SSD addition to the cache pool for capacity expansion. However, removal of SSDs from the pool is disallowed to prevent potential loss of write cache data. In the event of an SSD failure in the cache pool, the SSD cache pool's status degrades. Write cache halts, and write cache data starts flushing to HDDs. Read cache data remains operational, but no new read cache data enters the SSD cache pool. To avert cache pool failure, SSDs can be designated as dedicated hot spares in the SSD read-write cache pool. Inserting a hot spare, initiate rebuilding until completion, subsequently restoring SSD read-write cache service. The following describes the cases of read-write cache. In SSD read cache, the processes of read-write data will be disassembled to the following cases. Read data with cache miss. Read data with cache hit. Write data in SSD read cache. Besides, in SSD read-write cache, the processes of read data are the same as above, but the write data is different. The processes of write data will be described on following case. The figure shows how the controller handles a host read request when some or all of the data are not in the SSD cache. 1. A host requests to read data. The system will check if the requested data is in memory cache or SSD cache. If not, it is called cache miss. 2. Data is read from the HDD volume because of cache miss. 3. The requested data is returned to the host, and the system will check whether the requested data is hot data. 4. If it is, the SSD cache is populated. This is how the controller handles a host read request when the data is in the SSD cache. 1. A host requests a read data. The system finds that the data is in SSD cache, so it is called cache hit. 2. Data is read from the SSD cache. 3. The requested data is returned to the host. 4. If there is an SSD cache error, data is read from the HDD volume. The figure shows how the controller handles a host write request in SSD read cache. The write data can also be frequently accessed data and populated into SSD cache for next read. 1. A host requests to write data. 2. Data is written to the HDD volume. 3. The status is returned to the host. 4. The SSD cache is populated if the write threshold is reached. This shows how the controller handles a host write request in SSD read-write cache. The write data stays in the SSD cache for a while and will be flushed to the HDD volume at the appropriate time. 1. A host requests to write data. 2. Data is written to the SSD cache. 3. The status is returned to the host. 4. Data will be flushed to the HDD volume at the appropriate time. The actions that read data from the HDD and then write to the SSD are called populating the cache. Typically, this is a background operation that immediately follows a host read or write operation. As the goal of the cache is to store frequently accessed data, not every I/O operation should trigger a cache population, but only ones that pass a certain threshold, implemented as a counter. There are both a populate on read threshold and a populate on write threshold. When the same data block to be read over the threshold, it is called hot data and is populated to the SSD cache. The threshold must be greater than or equal to 1 in SSD read cache or SSD read-write cache. The value is forbidden to set 0 because of no action in read cache. The maximum of the threshold is 4. If larger than 4, the frequently accessed data is hard into SSD cache, so there is no obvious effect. When the same data block to be written over the threshold, it is called hot data and populated to the SSD cache. The threshold must be greater than or equal to 0. If it is set to 0, no action is performed for a write cache. The value must be greater than or equal to 1 in SSD, read-write cache. The value is forbidden to set 0 because of no action in write cache. The same as above, the maximum of the threshold is 4. If larger than 4, there is no obvious effect. Each cache block on a HDD volume has a read and write counter associated. When a host requests to read data located in the cache block, the read count is increased. If the data is not found in the cache, and the read count is greater than or equal to the populate on read threshold, then a cache populate operation is performed concurrently with the host read operation. If a cache hit occurs, the data is immediately returned from the SSD cache, and a populate operation is not performed. If the read count is smaller than the threshold, a populate operation is not performed. Write cases are the same scenario as read. This table summarizes the detailed SSD cache parameters. It is very easy to create SSD cache pool. Please notice that if you only select one SSD, then only the read cache option is selectable, and write cache would be grayed out, which means it is necessary to use at least 2 SSD for SSD write cache. In this demo test case, we select to SSD. Here can see, there can be read cache or write cache. User can also accord their application environment to select different I/O type. We provide 4 policies: database, file system, and web service. We also provide customization policy. User can customize the cache block size as they need. Select the volume which needs to enable SSD cache. In this page, you can see the SSD cache pool created successfully with ease. We also support to extend SSD cache capacity. You can add new SSD into this SSD cache pool online. Due to our NRAID and NRAID 1+ design, there is an SSD capacity limitation to add new SSD in this case. In this page, user can select the volume which needs to enable SSD cache. User can also observe the cache used information here. During the auto-tiering taking effect, you can also monitor all SSD cache use status. First, this feature is license required. You can submit our trial license for 30 days to experience the higher performance by this function. Please notice that our SSD cache license is enabled per backplane. If the user replaced the chassis with backplane, like disk roaming, the SSD cache would be disabled and need to activate license again. In SSD read-write cache, the write data will be flushed to the HDD volume in the following situations. 1. Flush data to the HDD volumes before the SSD cache pool is deleted. 2. Flush data to the HDD volumes before the related volume is disabled. 3. Flush data when the system is idle. It will take time to flush data from SSD cache to HDD volumes. Please do not remove SSDs before complete flushing. Otherwise, it may take risk of losing data. In addition, to avoid taking a long time to complete flushing, please make sure the front I/O traffic is not heavy when deleting SSD cache pool. It won't flush data to the HDD volumes when system goes shutdown or reboots. SSD cache is a game changer for storage performance and system efficiency. Leveraging solid-state drives accelerates data access, reducing latency, and improving user experience and productivity. With intelligent caching algorithms, SSD cache strikes a perfect balance between cost-effectiveness and performance gains, addressing traditional disk bottlenecks and supporting future scalability. Incorporating SSD cache empowers organizations to unleash the full potential of applications, databases, and virtualized environments, driving innovation in storage solutions. Embracing SSD cache is a strategic imperative for businesses to stay ahead in modern computing. Let's embark on this transformative journey together, unlocking unparalleled performance and efficiency. Thank you for your time, and let's explore this exciting technology